Hello guys, welcome back to another Cognitive Education video. Today we're going to be doing our Algebra 1, Unit 1 cumulative review. Okay, so first we're going to start by, we have 40 questions to get through. So um, I'm just going to answer them, go over each one, and just follow along. I'll explain each one. So I think it'll be better if I just paste each one in because I will. It's gonna get tiring writing them over and over. So here, let me get them. Okay, number one, classify number 12 using the smallest possible category. Um, well, looking in our definitions of what a natural, whole, integer, and rational or irrational number is, we're looking for the smallest, which means the smallest group. Obviously, there are a lot of rational numbers, but only a few within those rational numbers are going to be um, natural, yeah, or whole. So we got to choose the smallest group. Like, you can't simplify it any further. It doesn't fit into any smaller description. And so for negative 12, it'd be integer, which I hope makes sense. If it does not, you should watch the, I think it was lesson 1. Yeah, it was lesson 1. Okay, next. Which is irrational? So 0.785, it can be expressed as a fraction. We know that if it can be expressed as a fraction, it's not irrational, it's rational. So that can be expressed as 3/4. And then square root of 16, what number multiplied by itself equals 16? 4. That's rational. Um, I think you see that there, but we're gonna look at negative 4. That's a integer rational number. And pi 3.14, just repeating infinitely, that's obviously irrational. So it's C, pi. Okay, question 2. Okay, is every integer rational? So we know integers are one, shoot, is 1, 2, 3, -1, -2, -3. They can be 0. So these are obviously all rational. So I think we can conclude that every integer is rational. I mean, these can all be expressed as a fraction, -3 over 1, 0 over, I mean, anything that's not 0. Like, yeah. Is every rational number an integer? An integer can't have any decimals or can't like, yeah, it can't have any decimals. And so rational number can be 3/5. It can be expressed as a fraction, it's rational. That's like 0.6. That's obviously not an integer. So for this, yes. For this, no. Okay. Arrange from greatest to least. Okay, so we're gonna have square root of 3 first. Instead of using a calculator, I want to approximate that. We know that uh, square root of 1 is equal to 1, square root of 4 is equal to 2, so we know it's going to be in between. It's going to be greater than it's 3. Greater than 1, but less than 2. So let's pick some value. We know that 1.5 times 1.5 is gonna give us, I believe, 220, 2.20, 2.25, yeah. Oh, yeah, 2.25. So let's say like 1.75. Yeah, is approximately 1.75, which I think it's around there. So let's look. Then we have -2. That's, yeah, let's write out a number line first. So we have -5/2, which is, I hope you can evaluate that. It's -4.5 because we have -4/2 plus a -1/2. This is just 2, this is 0. Neg oh, I see where I went wrong. I wrote down negative. Okay, -2.5. That's -2. This is adding a -1/2, so you get 2.5, -2.5. So this is -2, and it's 1.5. Square root of, oh wait, be right back. Sorry for the short delay. Okay, so we're gonna have, I was gone for a little. Oh, this is the square root this is the same thing as the square root of 4 times -1. There's just some imaginary one right there. So we have square root of 4 is 2, so we get just -2. So we have 2 of these. So we know, looking at this, our smallest value is -2.5. And then we have our -2. That's our only other negative value. So we have these two -2's. We have -2, and we have negative times the square root of 4. And then we have, C, we have square root of 3 is 1.75, approximately. We saw that we plugged in 1.5 and squared it, and it did not, it gave us 2.25. That's a little smaller than 3, so that means 1.5 must be smaller than the square root of 3. And we have square root of 3. So since a number line is from least to greatest, we can just order it like that. How we got it, -2.5, -2, and negative square root of 4, 1.5, and square root of 3. Okay. A number is irrational and positive. Which must be true? Okay. I think there was supposed to be multiple choice for this, but there wasn't. But I'm just gonna say, just think about an irrational number that's positive. What must be true? It cannot be expressed as a fraction. Expressed as a fraction. That looks like a 0. And yeah, like, which is just p divided by q, where these both are integers. It cannot be expressed like that. Okay. Then we have a simplification problem. We're starting to get to our less conceptual stuff. Okay. We have simplify this. So, you should remember this, but these are absolute values, and the way absolute values work is they tell you how far a number is from 0. So for negative numbers, it just makes them positive, and positive numbers keeps them the same. So they'll always result in the positive of that number. That's what I'm saying. So absolute value of -8, it just becomes 8, plus the absolute value of -3, which becomes 3, minus the absolute value of 5, which is 5. And the minus is outside the absolute value, so don't mess up because of that. So we get 8 plus 3 minus 5. We do this, we get 11 minus 5. That gives us 6. Okay, next problem. Solve. Okay, solve this. So immediately you might say 7, but this is an absolute value, which means that we have two values. We have where this absolute value is x or where it's -x. Because the absolute value of a negative number is just the positive of that number. So when we have x, we just have x is equal to 7. When we have negative x, we have negative x is equal to 7. So x is equal to -7. Plugging both of these in for x, absolute value of 7 is equal to 7. That's just 7. Absolute value of -7, it's also 7. So both of these are true and valid solutions. Okay. Now we have next couple problems. Is this always true? So let's see. -4 plus 10. We don't do any absolute values yet. We don't turn this positive because look, this is all inside the absolute value. So this can be seen as the absolute value of -4 plus 10 in parentheses. And remember, PEMDAS, you always do the parentheses first. So we get -4 plus 10 is the same thing as 10 minus 4. So we get absolute value of 6 equals absolute value of -4, which is just 4, plus absolute value of 10, which is just 10. Absolute value of 6 is 6. We get 6 is equal to 14. So this isn't true, obviously. 6 is not equal to 14. Okay. Now we have something conceptual again. Okay. We have to identify this property. As you can see, I'll just point it out real quick. You're distributing the 7. 7 times A plus 7 times B. Distributive property. Okay. Question number 10. Another one. People usually skip out on this property because it's so basic. I mean, it is, but most of them don't memorize it. 3 plus 5 in parentheses plus 7 is equal to 3 plus 5 plus in parentheses 5 plus 7. This is the associative property of addition. I'm pretty sure it is. Yep, okay. Now we're done with the first 10. We're moving on to section 2 or unit 2. Okay, evaluate this. Exponents first, so 8. Oh, let me switch colors. We get 8 plus exponents first, so we get 3 squared is 3 times 3, which is 9, times 2 minus 5. We don't have any parentheses, no exponents, so next is multiplication, division. We have multiplication right here, so we get 8 plus 9 times 2, which is 18, minus 5. Then we do addition and subtraction from left to right, so 8 plus 18, which is 26, minus 5, we get 21. Okay, now we have this, number 12, evaluate. Okay, we have 20 divided by 2 plus 3. We do parentheses first, then PEMDAS. So we get 20 divided by 5 times 4 minus 6. And then we have multiplication and division from left to right. So we have 20 divided by 5, which is just 4. 5 times 4 equals 20. Times 4 minus 6, then we do this, we get 16 minus 6, which is equal to 10. Okay. Okay, evaluate this when x is equal to 3. So what you should do first is just plug in -3 in parentheses to each one of these. -3 squared, -3 times -3 is 9, because two negatives multiplied together makes a positive. So we get 4 times 9 minus, well, this is the same thing as plus -3 times -3, and that we just talked about this. Two negatives multiplied is a positive, so we just get this, all of this right here, because this is plus the negative of this, and that's just the same thing as minusing it, so we're not really changing anything. So this evaluates to be 9, so we get plus 9, plus 7. 4 times 9 is 36, plus 9, plus 7. We get 45 plus 7, which gives us 52. I hope that's right. Yep. Okay. Okay. Here, we want to find the mistake. Okay, we have run out of room on this page. We're gonna go on to the next page. Okay. 14. We have this expression, x squared plus 5. Oh my gosh, I accidentally, yeah, just don't look at that. Yeah, just forget we ever had that down. So we're gonna have this, find the mistake with the expression x squared plus 5x, and we're supposed to find it, evaluate it when x equals -2. A student wrote this, find the mistake they did. So when we plug it in, we get -2 squared is 5 times -2. You can see over here they wrote +2, so that's their mistake. They forgot to times 5 by -2. Okay. Now we're gonna look at algebraic expressions. 5 more than 3 times a number. I did it again. Okay. Okay, gotta start paying attention now. Okay, just don't like try this. Don't look at the answers that I keep on accidentally showing. Okay, 5 more than 3 times a number. So we have 3 times a number, so let's just say n. 3 times n, because that's just 3 times n. Yeah, 3n. And then 5 more, so we're adding 5 to it. Okay. Difference between twice a number and 7. So twice a number, so 2n, that's 2 times n, that's twice of n. Difference, so minus. You're finding the difference between these two. 2n minus 7. Identify coefficient, variable, and exponent. So our coefficient is -9, because that's what's being multiplied by our variable. And our variable is x. And then our exponent is 4. Okay. Now we have evaluate this when a is equal to 5 and b is equal to -2. So when we substitute, we get 5 plus -2, which is just -2, squared minus 2 times 5 times -2. So we get this is 3 squared. -2 times 5 is -10 times -2 is +20. So we get plus 20. 3 squared is 9, so equals 29. Okay, simplify this. We get 3 square, we do parentheses first. So this parentheses, we're gonna have 2 cubed, which is 2 times 2 times 2, which is 8, minus 5, which is gonna and give us 3. So we have 3 squared plus 4 times 3. We do this exponent first. We get 3 squared is 9 plus 4 times 3. We do multiplication next. We get 12. That lastly gives us 21. Okay. I don't know why this is a part. I'll just show it. I'm not gonna do it because we haven't even gone over this, but for some reason, one of the practice questions is this. I'm not even gonna talk about that because we're like far away from that. That's like one of the last units. Yeah, just like do not look at this. Just know that a plus b, all of that squared is not equal to a squared plus b squared. But please don't like actually try to prove that. Okay, we have section 3AK, unit 3, simplifying expressions. Okay, new color, I'm gonna use green. Okay, 7 of x plus 3 of x. In total, you have 10 of x now, minus 5. Okay. Usually I'd rearrange the equation, but I'm hoping that all of you at this review hopefully know the basics of simplifying and don't have to rearrange the equation anymore. So we have 8a in the equation, and then we're adding another 2a, so it's gonna be 10a, and we're taking away 3b, but then we're adding 5b, so we're adding 2b. So we get 10a plus 2b. Okay. Now we have this. Simplify. Oh, okay. So we have 4 of x squared minus 2 of x squared. Get 2x squared. We're adding 3 of x. We're also adding 5 of x. So we're adding a total of 8 of x. And we're taking away 7 and we're adding 10. So in total, we're adding 3. Okay. Simplify, you use the distributive property, you do 3 times 2x, which gives us 6x, and minus 3 times 5, which is 15, plus 4x, we have 6 of x, and then we're adding 4 of x, so we get 10x minus 15. Okay, gonna go like right here, yeah. Simplify, we're gonna distribute, it says that over there, thanks. Yeah, we're gonna distribute -2. -2 times 4x, we get -8x plus 3 times -2, which gives us -6. And then we're gonna be adding all of this to it. Or yeah, that's the simplest way we can do it instead of just having a -1 and distributing it to everything. So we're just gonna act like this is -2 times 4 plus 3 plus -5 times x minus 2. Okay, so we just did this. That's already simplified. -5. Remember when you're adding something like plus -5x plus 10 minus 2x squared, it's just going to stay the same. You're going to have a minus 5x plus 10 minus 2x. So when we distribute this, eventually we get -5x minus 2 times -5, which will be plus 10, because the negatives cancel out. So we get -8x minus 6. Remember, these stay the same, so minus 5x plus 10. We're taking away 8 of x, and then we take away 5 of x. In total, we took away 13 of x, and we're taking away 6, but we're adding 10, so in total, we're adding 4. Okay. Why is this wrong? First of all, these aren't like terms. They have the same variable, but the variable isn't raised to the same power. This is x raised to the first power. This is to the second. So you can't combine them. They're not like terms. Okay. Are these like terms? No. Oh my god. Yes. They have the same variable raised to the same exponent. Coefficient doesn't count. Coefficient is just what's being multiplied by the variable. So they're like terms if they have the same variable raised to the same power. Okay. Another one with a lot of terms. Okay, so we have 6 of a squared, and then we're taking away 3 of a squared. So we have 3 of a squared, and we're taking away 4 of a squared. We're taking away 4 of a, and then we're adding 7 of a. So total, we're adding 3 of a. And then we're adding 8, but we're taking away 12. So in total, we take away 4. Something felt wrong. No, that's right. Okay. We have simplify this. Distribute the -3. I'm not gonna talk about it. I hope you guys have gotten used to distributing. So we have -6x plus 12 plus 10x plus 2. We have we're taking away 6 of x, and then we're adding 10 of x. So in total, we're adding 4 of x. And then we're adding 12, and then we're adding 2. So in total, we're adding 14. Then we have number 30. Solve. Yeah, we haven't had a lot of solve for x. Yeah. So we have, oh, that's because that's next unit, but we have 3 of x plus 2 of x. So that gets us 5 of x plus 5 equals 25. You minus 5 for both sides. This cancels out, and we get 5 of x equals 20. You divide by 5 on both sides. This cancels out. We get x is equal to 4. Okay. Last set of problems, Unit 4. I wonder how long it's been of us doing these practice problems. Let me check. Oh, 30 minutes so far. Okay, about 30 minutes. That's not bad. Okay, last color switch. What are we going to use? Yellow. Yeah. Simplify. So this is the same thing as... Well, remember, when you have ratios like these, if you multiply both sides or divide by the same thing, it stays the same. So what's the greatest common factor of these? That's, I'd like to say 6. Yep, I think it's 6. So it'll become 3, 4 when you divide both sides by 6. Then we have this, and then we can just simplify 6/12 into 1/2 since 6 is half of 12. So, or you can divide this by 6 and this by 6. It's equal to 1/2. You can do cross multiplication if you want. We'll get into other ways to solve this besides cross multiplication, but that's all we've learned for now. So you get 2x is equal to 8, and then you divide both sides by 2. You get x is equal to 4. Okay. Just gotta speed run through this last couple questions, and we'll be done. Unit 1. Okay, we have x plus 3 divided by 5 equals 12 divided by 20. Cross multiply, you get 20 times x plus 3 is equal to 12 times 5, which is 60. You distribute this, you get 20x plus 60 is equal to 60. You minus 60 from both sides. This becomes 60. You get 20. X is equal to 0. Divide both sides by 20. I mean, it's kind of pointless, but you get x is equal to 0, which feels a bit wrong, but no, it's right. Okay, find the final price of the jacket. We have a $60 jacket and we put a 30% discount. So what that means is we're taking 30% off. So it's going to be 70% of the original price. Because at first we have 100% of the jacket's price, but we're taking away 30% of it. So it's just going to be 70%. Just 0.70 times 60, which gives us 42. Yeah, that's how you draw the money symbol. Okay. Okay. Increase from 80 to $100. Find the percentage increase. Okay. So we know the formula: new minus old divided by old. So we're going to have 100 minus 80, which gives us 20, divided by 80. Divide both sides by 20. You get 1/4. So 0.25 or 25% increase. Okay. Decrease. Now we have decrease. From 50,000. So you can do this the same way, I think, but you're in the end, you're gonna have to say that it's a decrease. Hmm. Yeah, you're gonna have to say it's a decrease. So you're gonna have 50,000 minus 42,500, which I think is 7,500. Yeah, 7,500. No, I think our original. No, we still do the same. Also, so our old one was this, our new one is this. I just did this minus this, because essentially what this is, we can rewrite this formula. We only do this most of the time to make it a little simpler, but it's just the difference divided by old. So we do new minus old to simplify it, but I just found the difference. Okay, and so divide by 50,000, we divide both sides by 1,000? No, 100, right? Yeah, 100. We get 75 over 500. We divide both sides by 5. we will get 15 over 50. We can divide, so we get 3 over 10. So yeah, we went wrong somewhere. Oh, yeah. So just evaluate this as it is, whether you want to simplify, but you get 0.15. So a 15% decrease. Okay. Two 20% discounts. Is it 40%? So this, let's like say we have a number X. Take two 20% discounts. That means taking 20% off, so it just becomes 80%. So we get 80% of X, and we take a 20 discount. So, and then, so we have 80% of 80% of X. So 0.8, that's just 0.8x times 0.8. 0.8 times 0.8 is 0.64 or 0.064. No, 0.64. So you get 0.64x. So no, it's not 40%. It's actually 36% discount. Okay, compare scores. Okay, we can see student. We can simplify these, or you can plug them into a calculator, but I'd rather have you simplify these because they're pretty easy to simplify. Times both of these by 2, you get 84 divided by 100. So that's just 0.84 or 84%. That's student 1. Student 2, 75 divisible by 9? Seems like it would be. No, it's not. There is not really a way you can simplify this. I mean, I guess to an extent you would, but if I was you, I'd just let you plug this into your calculator, and what you do get is you get 0.833 repeating, so that's 83%, 0.3. So student 1 did better. Okay. Okay. What happens when you have a... Oh, let's move this. We're almost done. Create when... So let's start with... Let's do this 100. You increase it by 25%, then you decrease it by 25%. In total, what was the percentage change? So increase it, so you add, or well, it's already at 100%, so you're doing 125%. So 100 times 1.25, that's the same thing as moving this decimal twice, so we get 125. Then we decrease it, so we times it by 0.75. And 93.75. And then we use our difference divided by old formula, and we get 6.25 divided by 100 which just gives us, oh, okay. Yeah. Um, yeah, dude. Okay, wait, give me a minute. Okay, my bad, I'm back. Okay, so we're gonna have this, and then we know it decreased because this is less than our original. So this is gonna get moved back twice, but then to get a percentage out of a decimal, we're just gonna times it. So it's by 100, so it's gonna go back. So we get 6.25% total. Okay, decrease. Okay, last question. Price increases 40%. What decrease returns it to original? So we have it increases 40%. It's already at 100%. So we get 1.4x. What decrease returns it to its original? So, hmm, I mean, we could use an example. Yeah, we could times a. We could try this route. Okay, so we can write out this thing as 1.4x times some quantity a. It gives us back x. We can divide by both sides by 1.4x. This cancels out. 1.4x. This cancels out. So we get a is equal to 1 divided by 1.4, which is approximately 0.714. Let's just put 0.714. And then that's of course like the total, but we know this isn't the decrease. This is just the effect of the decrease. So we have to do 1 minus 7.714, which gives us 0.286. So in total, rounding, we get around 20, well, we won't round, 28.6% decrease, which is right. Okay, thank you for watching this review, and I hope all of this helped you get ready for Unit 2, which I honestly forgot what Unit 2 was going to be. Let me check. Okay. Oh, yeah, here I found it. Unit 2 is going to be equations and inequalities. That's going to be fun, because that's one of the biggest foundations you can have for this class. Well, we did a lot of stuff. Here's all our stuff together on one, like merged all together on one big whiteboard. Yeah, it isn't pretty. But this was 40 questions in total, and I hope you tried or attempted some of them. But thank you for watching the video, and I'll see you in another one.